Hi everyone, my name is Rishika Dwivedi. Today I'm going to take you through my Python project where I use big data tools and techniques from data retrieving to getting insights. The first part was data retrieval from the API. This is the API that I used, Polygon IO. I try to get the tickers data from here. Let me walk you through the code or the Python script. This is the Python script I wrote to fetch stock ticker data from Polygon IO's API. I've imported several essential Python modules like time to manage delays between API requests to avoid hitting rate limits, and then func tools to use decorators for logging function execution, time and calls, and then requests for making HTTP requests, and JSON to save the saved fetch data, to save the data. This is a config file where I have my API keys. A list of my API keys are stored in this file to keep it secure because it's the sensitive information. Because APIs often require authentication, I stored them securely in this config.py file. The base URL is the endpoint for API. I have defined constants like fetch limit, rows per request, delay between requests to control data fetching process. And then I have added decorators for logging to monitor the performance of script. I have written two decorators, which is log time and then a log call. Log the execution time of any function it wraps, and the second one is to log when a function is called and arguments passed to it. We have fetch data function. This is responsible for making API calls. It constructs the request URL using the base URL and API key and query parameters, limit and offset. If the response is successful, status code 200, it returns the results. If the API rate limit is hitting, then function waits for 60 seconds before retrying. Any other errors are logged for troubleshooting. This ensures we fetch data in manageable chunks while respecting rate limits. And then fourth, the next part is collecting data in batches. The collect data function orchestrates the entire data collection process. It uses multiple API keys to switch when one key reaches its limit. Initializes variables for all data and total rows and offset. It loops until the fetch limit is reached, fetching data in batches of rows per request, and switches to next API in the list after each request is preventing a single key's limit. It also includes a delay between requests to avoid trigger rate limits. This method ensures efficient data collection without any interruptions. And then we have save data function. Once the data is collected, it is saved to the JSON file. And then we do have the main function. The main block ties everything together. When the script is executed, it collects data from API and saves it to a file. And this is my JSON file. Now that the data is collected, taking it further to a big data platform for ELT. Basically, here we're doing loading and transforming. I used Cassandra. Now that the data is collected, in order to connect to Cassandra, I used required Python packages, which allows interaction with Cassandra database. The script uses cluster object from Cassandra driver to establish a connection. I connected to Cassandra, and this is my key space tickers where the data will be stored. As you can see, here are my tables in tickers. I have all these tables. We'll look into that. Here we are inserting all of that data into my Cassandra database. You can see all the 100,000 rows are inserted. And then this is basically my bronze table. Now that the data is collected, I'm taking it to a big data platform, Cassandra. In order to connect to Cassandra, I used required Python packages, which allow interaction with the database. This script uses cluster objects from Cassandra driver to establish a connection. I used a key space called ticker, where the data will be stored. And this is the data frame of my data. I'm checking the data types, and then I have created table to insert my data, and then I have inserted batch wise. You can see that it is reflecting that 100K rows are inserted into the database where I created a table, and I'm also checking for null values, which we don't have. The inserted data can be seen here. This is my bronze stock data, which is raw data stage in the Mendelian architecture. After establishing the schema and running the function and loading data into this table. Next, I created silver table to store data that has gone basic transformations and cleanings. For instance, filtering out records that have missing values or invalid data. However, we found none. And then I also removed the last updated UTC column because it was not very useful for the analysis. And then I imported the data into the silver table from bronze after transformations as well. This is my silver stock data. Taking it further, gold data tables are created to store high quality or business level data, usually after aggregations or additional processing. This is my gold table 1. This aggregates the number of currency pairs by base currency name, and market from the silver layer. And this provides a summary of currency pairs counts per market, offering insights into market liquidity and pair connection. It is my gold table 1. And then this is my gold table 2, which is about active currency details. This filters active currency pairs where active is true from the silver layer, adds market name and ticker details. The purpose was to focus on active currency pairs, making it useful for tracking trading data in various markets. And insertion is also completed. This is my gold table 2. And then we have gold table 3, which is currency pair info. This gives a description about the currency pairs. It fetches base currency name, base currency symbol from silver layer, creates a pair description by concatenating base and pair currency names. The purpose was to provide like a user-friendly description of currency pairs, which will be useful for forex platforms or financial analytics. And reflected is my gold table 3, which is currency pair info. And finally, visualizations to actually see what is the data about. Here I have installed required libraries and then connected to my database. This is my first visualization, a pie chart. It is created to display the percentage of currency pairs in each market. And then a stacked bar chart. This provides a clear view of how specific currencies are spread across various markets, helping to spot market trends. And then we have a bar chart that displays top 10 currencies by total pairs, excluding the currency with the highest pairs, which is USD. This visualization helps in identifying most popular currency, excluding the dominant one. It is observed that after USD, it's Euro. That brings to the end of this project. Working on this project, I really enjoyed diving into big data concepts. It was exciting to work with large data sets and explore how tools like Cassandra can handle such vast amounts of data efficiently. Transforming data through bronze, silver, and gold stages gave me a deeper understanding of how data processing workflows. The experience was not just about learning new techniques, but also about pushing myself to think bigger about more strategically how to manage data and analyze data at scale, bring big data and applying these concepts in future projects. Thanks for watching. Bye.